Day 336 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1534, count good triplets. The difficulty level is easy, but you already know we were going to keep the solution as simple and easy to understand anyway. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out the link in the description so you can get you some. Now let's see what the question says. Given an array of integers r and three integers a, b, and c, you need to find the number of good triplets. A triplet r of I, r of j, and r of k is good if the following conditions are true. 0 is less than or equal to I is less than j, j is less than k, and k is less than r dot length. The absolute value of r I and minus r of j is less than or equal to a. The absolute value of r of j minus r of k is less than or equal to b. And the absolute value of r of I minus r of k is less than or equal to c, where the absolute value of x denotes the where x denotes the absolute value of x. Return the number of good triplets. All right, y'all, that's a lot to take in right there. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input r equals an array of integers 3, 0, 1, 1, 9, and 7. A equals 7, B equals 2, and C equals 3. Output says the output is 4. Explanation says there are 4 good triplets, which are 3, 0, and 1. 3, 0, and 1, 3, 1, and 1, and 0, 1, and 1. So let's go ahead and break down this example a little further by walking through it. So first we see that the first triplet that they give us is 301, which is the first 3 integers of the array, right? And we can see that these integers satisfy these requirements, right? Because in this case, 3 would be I, R would be J, and 1 would be K. So when we go through these requirements, we see that 3 or 0 minus 3 is less than or equal to A, right? It's less than A because A is 7. So that fits that requirement. Then we have J minus K has to be less than or equal to B. So 0 minus 1 is going to be -1, which is less than B because B is 2, right? So they satisfy that requirement. But the last requirement we have to satisfy is I minus K has to be less than or equal to C. And in this case, 3 minus 1 is going to give us 2, which is less than 3, or which is less than C. So that's one good triplet, right? Boom. Then as you can see, we have 301 twice. So you can see that we have the same 3 and 0, but we have 2 1s. So that this triplet is using this one, then this triplet is using this one. So it's 2 different triplets, but it's the same principle and they all work. Now we do it with 3, 1, and 1, and let's walk through it. So 3 minus 1 is going to be 2, which is less than or equal to A, which is 7, so that works. Then 1 minus 1 is going to give us 0, which is less than or equal to B, which is 2. Then we have 3 minus 1, which is going to give us 2, which is less than or equal to 3, right? So 2 is less than 3, so that satisfies the requirement. So these 3 integers, or this triplet satisfies the requirements as well. Then we have a last triplet right here, which is 0, 1, and 1, and they satisfy the requirements as well, because when we do 0 minus 1, that's going to give us -1, which is less than 7. Then we do 0 minus this one, which is going to give us -1 again, which is less than B, which is 2. -1 is less than 2, so that satisfies the requirement. Then we have to do sorry y'all, that should be, 1 minus 1 is 0, which is less than B, which is 2, right? So that's why the 1 and 1 fits the requirement. And then we do 0 minus 1 again, which is -1. and that satisfies this requirement because -1 is 3. And those are all of the triplets, but remember, we're not returning this array of triplets. We're returning the count of this array of triplets, or the count of triplets that are in this array, which is 1, 2, 3, and 4. There's 4 triplets that we can create out of this array right here that satisfies these requirements, and we have to return the count. So the count is 4. We're not returning the actual triplets themselves. We're just returning how many triplets there are. So, and in this case, there are 4. So let's go ahead and take a look at example 2. It's the same principle, but it's a different case where there are no triplets that can be created, right? So in this case, we have the input equals an array of integers r, which is 1, 1, 2, 2, and 3, a equals 0, b equals 0, and c equals 1. The output is 0. Explanation says no triplets satisfy this condition. So there are no triplets we can create in this array that satisfy these requirements right here with this input A, B, and C, these A, B, and C inputs right here. So we're just going to return 0. So now that we understand the question, y'all, let's get into the fun part, the actual code. Code is quite simple and easy to understand, as I said it would be. So let's get started. Now, the first thing we need to do is we need to declare a variable that will keep count of the triplets, right? Because we're not returning the triplets, we're returning the count of the triplets. So we need a variable for that. So we could just come over here, declare a variable called count, and we can set that equal to 0. Now we need our first loop, which is going to pick index I from 0 to start up to array.count minus 3. So in order to do that, we're going to come right here. We're going to say for I in r dot indices dot drop last, open up the parentheses and put a 2. Boom. Then we're going to open up the brackets. And now the second loop is going to pick index j such that I is less than j and j is less than r dot count minus 1. And this is also going to apply the first condition where the absolute value of r minus r of I minus r of j is going to be less than or equal to a. So in order to do that, we are going to say for j in, open up the parentheses, I plus 1, come outside the parentheses, we're going to say dot dot less than sign, then we're going to say r dot count minus 1, then we're going to come underneath that and we're just going to say where at abs, open up the parentheses, r square bracket I, come outside of that, minus r square bracket j is going to be, come outside of the parentheses, less than or equal to a. So once again, that's going to apply the first condition where r, the absolute value of r of I has minus r of j has to be less than or equal to a. And then we're going to open up the brackets. Now we need our third loop, which is going to pick index k such that j is less than k and k is less than r dot count. And we need to apply the remaining 2 conditions, right? Which is the absolute value of r of j minus r of k is less than or equal to b, and the absolute value of r of I minus r of k is less than or equal to c. So in order to do that, we're just going to come right here. We're going to say for k and open up the parentheses j plus 1, come outside of the parentheses, dot dot less than, so up to r dot count. Then we're going to come underneath this again, and this is where we are going to apply the 2 remaining conditions. We're going to say where abs, open up the parentheses, r square bracket j minus r square bracket k is less, come outside of the parentheses, is less than or equal to b, and, so 2 and signs, then we could just come underneath that so it's easier to read. Then we're going to say abs, open up the parentheses, r square bracket I minus r square bracket k, come outside of the parentheses and say it's less than or equal to c. Then we're going to open up the brackets and we are going to say count and we're going to increment count by saying count plus equals 1, right? And that means we found a valid triplet. And then, but we still need to return the count, remember? So we need to come down here, and we could just say return count, and that's going to return the total number of good triplets that we have found. So let's go ahead and give this a run. Make sure it runs properly. Let's see. Okay, we have an error. Oh, sorry, y'all. This should be R square bracket K, not L. So let's run it again. See if it runs this time. And it's accepted, y'all. So let's go ahead and submit it. And look at that, y'all. 10 milliseconds beats 84.62% of users with Swift. Those numbers aren't too bad. We could get them up later, but for now, I feel like those are some good numbers as we're working to just expand our knowledge and understanding of how to solve these problems. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.